Good afternoon and welcome to the ILIKA PLC final results investor presentation. Throughout this recorded presentation, investors will be in listen-only mode. Questions are encouraged and can be submitted at any time by the Q&A tab situated in the right-hand corner of your screen. Just simply type in your questions and press send. The company may not be in a position to answer every question it receives during the meeting itself. However, the company will review all questions submitted today and will publish responses where it is appropriate to do so. Before we begin, I'd like to submit the following poll. And I'd now like to hand you over to Graham Purdy, CEO. Good afternoon to you, sir.
Good afternoon and welcome to all of our investors who have taken the time to tune into this presentation. I appreciate that those of you in the UK have got the choice between listening to this and going to the beach to enjoy the current heat wave that we've got here in the UK. So many thanks for your attention, and I hope that the presentation proves to be interesting for you. So I'm going to just skip over the introductions here. You've got myself, Graham Purdy, and Steve, our finance director.
Good afternoon.
I'm not going to go through our bios here because actually you can read them on our website and also look at LinkedIn for more information. So with that, let's move on to the main presentation. So as you know, ILIKA is a specialist in solid-state battery technology. We're one of the few global experts really in the design and manufacture of such batteries. There are two product lines that we have in the business. On the one hand, we have our Stereax miniature batteries, and you see one of our Stereax M300s on the end of one of our scientists' fingers there, so you can see how big they are. And then on the other hand, we have our Goliath solid-state pouch cells, which are designed for EVs and consumer appliances. And there you see one of our engineers holding a couple of those pouch cell prototypes. So first of all, an overview. These are our annual results. So we should start with, first of all, a summary of the financial headlines, which Steve will then go into in more detail later on in the presentation, plus our outlook. So really the shape of our financial headlines is driven by the fact that we have raised significant funds last year in particular to invest in Goliath. So we had a net raise of about £25 million, and we said that we were going to invest that in R&D for Goliath and equipment in order to increase the degree of automation in our pilot line, and that's what we've done. But that still left us with a healthy cash balance, which was just over £23 million at the end of April this year. So how does that position us going forward? Well, first of all, we're progressing the scale-up of Stereax, really through the fab implementation that we started in 2021. We opened our fab at the end of last year. We've now completed the process qualification, and we're now entering a phase of process optimization where we're systematically increasing the yield of the process and also creating batches of product for qualification to allow us to then commence commercial sales in 2023. The Goliath technology is being matured with partners that we've been working with through a series of defined technical milestones, and I'll come back to this and talk in more detail about that. And both of these programs are really set up to address the building commercial opportunity for our technology, which is still very much present across large addressable markets, and that's going to provide a fantastic platform for future growth. So let's start first of all with a review of progress of our Stereax batteries. Again, for scale, you can see one of our M300s next to the head of a pencil. And this ultra compact nature of the Stereax cells makes it really suitable for the miniature medical implants that we've designed it for. Also, actually, of real importance is the ability of these batteries to deliver pulses of power, both for the types of therapies that the batteries are designed for and to enable communication. So we often use Bluetooth chips, which send packets of data from the implant through to an information relay device, often a mobile phone, that allows the information then to be uploaded into the internet for further analysis. And also, these batteries are very safe, very inert. There is no toxic fluid, in contrast to lithium-ion batteries that can leak and cause harm to the patient. And the addressable markets for these miniature medical implants are very large. One of the important themes in healthcare at the moment is really this transition from pharmaceuticals to electroceuticals. A good example of that is actually the desire to address the opioid crisis in the US, where very strong painkillers have been administered to sufferers, in particular of back pain. And this really demonstrates the limitations of prescription drugs. So electroceuticals are an alternative to that, where small devices are used to deliver low currents of stimulation to the peripheral nervous system. So that's the part of the nervous system outside of the brain and the spinal cord. And of course, that nervous system connects both the brain and the spinal cord to different organs and limbs in the body. And so you can address specific sources of pain very effectively using these types of stimulation devices. So one of the key nerves that is part of the peripheral nervous system is the vagus nerve, and that's one of the 12 important cranial nerves that connect the brain to the body. It's a bit of a superhighway, really, from the brain, and connects to lots of very important organs, and that allows specific therapies to be developed for a range of important conditions. Some of the biggest healthcare concerns, actually, that the modern world has to deal with, including things like obesity, rheumatoid arthritis, and this is a real growth opportunity for the application of these nerve stimulation devices. And also, perhaps of importance is some of the smaller addressable markets, but nevertheless markets that you can get to market relatively quickly, such as smart orthodontics. So the opportunity here is actually to use these sensors and miniature batteries to power devices that can then allow people to monitor the use of braces or retainers and aligners, to make sure that patients who are prescribed such devices do use them, but also actually to diagnose conditions in saliva, such as measuring pH for proxy for tooth decay, glucose, of course, which is useful for diabetes, and then electrolytes, which can be used to diagnose chronic kidney disease. So these need very small batteries, as you can imagine, that would fit into your mouth and enable you to power such devices. So how do we make money? How do we make a return for our investors with these applications? Well, this is our business model. I mean, ILIKA is very clearly a manufacturing business at the moment. We have established our mid-scale fab for the production of Stereax cells. We do most of it in-house, but some of it is outsourced. But we get orders from our customers, which we then fulfill with product delivery. However, our ambition is not to build a string of fabs or factories in order to meet growing demand, but rather to license the technology, which we're planning to do from 2024 onwards, so that our biggest customers can either establish their own facilities. Some of the big medtech companies actually manufacture a lot of the components themselves, or indeed to allow contract manufacturers, so tier one suppliers, to manufacture the component at large scale on our behalf under license. So in terms of where we are with the implementation of our fab, I think we were very proud, justifiably proud to have installed the equipment and built the fab in a few short months in 2021, in the teeth of what was perhaps one of the most disrupted supply chains within living memory. And there you see our local MP, Steve Bryan, opening that facility just before our Capital Markets Day in December of last year. We've now gone on to substantially complete process qualification. And this is what that process looks like. So we start with wafers. We use a reactive evaporation method in order to make the cathodes, which are the positive electrodes in our Stereax cells. We then pattern those cathodes in order to get the right form of battery, encapsulate them before outsourcing the thinning of the wafers and their dicing and their stacking into functional stacks. And then we bring them in-house for the formation part of the process and evaluation of the cells before they're dispatched to customers. So we've got a combination of proprietary know-how associated in particular with that reactive evaporation step and established industry processes, particularly at the back end of the wafer processing. And that process qualification, as I mentioned, is now substantially complete. And now we're moving into that process optimization or yield enhancement phase and product qualification. So we were unfortunately somewhat delayed with the completion of our process qualification. And that really revolved around a tool that we referred to as Tool 1 in the past. That's this reactive thermal evaporation step. It's a one-step deposition of the cathode material. We use lithium cobalt oxide for that, which is widely used in the electronics industry. And unfortunately, the main reason for this is that the process conditions that we had on our pilot line weren't directly transferable into Tool 1. And that led us to have to announce that the process qualification was taking longer than planned, and therefore actually our revenue recognition would be pushed out into 2023 to give us time to complete the process optimization and then product qualification before we start shipping products to customers. So in terms of what that ramp up looks like going forward, in the second half of the year, so actually the half that we're in now, we've got process optimization that's ongoing. That should allow us to ship product in 2023. And really the ramp of those product sales is determined by the aggregated demand from customers, in particular in the medtech space, as they move through preclinical studies, which require a relatively modest amount of batteries, through to the first clinical trials, and then extended trials leading to regulatory approval and then mass production thereafter. And just to give you some comfort that there is sufficient commercial demand to fill our fab, this is an extract from our CRM, so our Customer Relationship Management database. You can see that we've anonymized the company names, but we've indicated where they're located. A lot of our customers are located in the US. Some of the biggest medtech companies are located in the US, and so that makes a lot of sense. You can see actually that there's a spread of customers between modestly sized startups through to NASDAQ listed multinationals. The startups actually are pretty important to us, perhaps because they often develop interesting technologies which are then later acquired by the larger multinationals, and so your end customer ends up being a very powerful organization that has good access to the addressable market. And then when you sum up the SOM, or the serviceable obtainable market numbers for the number of batteries that we would sell, that's in the final column, you come to the conclusion that we're going to exceed the total capacity of our fab, and that's what really gives us the springboard through to licensing opportunities so that we can make the technology available to those bigger organizations who either have a facility in-house for manufacturing components or to allow them to outsource to tier 1 contract manufacturers and have the product made and the license. And some of those conversations are in gear right now. So that concludes the slides on Stereax. Let's change gear and talk a bit about Goliath. So Goliath is our pouch cell technology for EVs. You know, some of the unique benefits of Goliath large format solid state batteries are similar to the benefits that make them interesting for medical devices, but there are some subtle differences. So obviously the ultra compact nature of solid state is really attractive for EVs. There are lots of EV designers that are looking for smaller, compact battery packs for their vehicles. But also the high temperature tolerance of solid state cells has an impact not only on the safety, so it's a non-flammable design, but also actually it reduces the battery pack size and weight. So in a state-of-the-art battery pack, about 35% of the battery pack is parasitic. By that, I mean it's not taken up with cells, it's taken up with the framework around the cells and the weight associated with the cooling system. So a normal lithium-ion battery is happy to operate at about 40 degrees C, but beyond 60, it starts to swell and the pack can split. And when that happens, you've effectively got a spillage of flammable liquid, and that can lead to very intense battery fires. So with solid state, that risk doesn't exist. Our version of solid state will operate safely up to about 120 degrees C. So it means that you can reduce the size of that cooling system and therefore the weight of the battery pack. There's also some benefits around the environment. So it takes less energy to manufacture solid state, and that is largely related to the lower number of cycles that you need to put Goliath batteries through before the batteries are formed and stable, ready for sale. But also it's easier to recycle these cells because when you come to take them at the end of their life, you remove the packaging. There's no liquid electrolyte to have to handle. So there's no risk of fire or indeed toxic liquid spillage. So you can crumble those cells and then extract the metals from the powder and put them back into the supply chain. probably don't need to convince you actually that there is a big addressable market. This is actually a chart from Bloomberg NEF, which charts the growing demand for solid state. So most analysts that cover the sector are equally convinced of the inroads that solid state will make. And that is borne out really by the broad interactions that we've got with OEMs. So, how can we meet this demand? Well, really, it boils down to making sure that we move our technology up the technology readiness curve, up this S-curve that I've plotted here, which has a series of technical milestones, taking us from where we were at the end of last year at M0 through D2, which is a data point, and P1, which is our first product that we will issue to our partners for evaluation, and then crossing lithium-ion equivalence into MVP, so minimum viable products readiness and beyond. And the S-curve for traditional lithium-ion cells is shown in dark blue. That's really the top end of that S-curve. Goes back to the 1990s, really, and it's a technology which is reaching maturity and that is now in the zone of maximum theoretical energy density, where not much else can be tickled out of the cells, and it will be surpassed by the new technology associated with solid state. And in the second half of that slide there at the bottom, you can see the effect of solid state on gravimetric cell-to-pack ratio, quantifying that as a gain from about 60% to closer to 75, even 80% over the next 8 years or so. In terms of technical progress over the last year, this has been really strong. I think that's demonstrated by the movement up that energy density curve that we were just looking at. We've improved the number of cycles without failure. We've got demonstrated room temperature cycling, which isn't always possible with solid state. We've got an increased cathode utilization capacity, and we've also got batch reproducibility of baseline performance. There's a video you can look up on YouTube which shows how robust our cells are, both mechanically and also their non-flammability. We demonstrate that actually by cutting one of these cells in half and showing actually that it still functions even after you've done that, and there's no leakage of any flammable liquid from the pouch when you do that. So in terms of really what's happened over the last quarter, we've moved into that data point approaching D2, which is a steep part of that development curve and is putting us onto a trajectory to intersect normal lithium-ion cells by the end of the year. So how do we commercialize this technology? Well, we've chosen to market it into the supercar or hypercar segment. And the principal reason for that is that when we first manufacture this at what we call mega scale, so not in a gigafactory, but in a mega factory, the price point won't be as low as the commoditized price point that is achieved by some of the large-scale production, which is managed by some of the incumbent companies out there like LG Chem and Samsung and BYD and Cattle in China. We won't be able to get to that price point. We will need to be able to sell to customers who can tolerate a higher price point because they wish to access the benefits of solid state. And supercar and hypercars moving into some of the luxury brands for the mass market will be how we first commercialize our technology. So how do we make enough product available in order to support that rollout? Well, this is the scale-up plan that we have in place. So we've done some of the early pre-pilot work with OEMs that you see listed there, so Honda and JLR and McLaren. And more recently, over the past quarter, we've been doing work with Comau, which is part of the factory industrialization arm of Fiat, now part of the Stellantis group, making sure that we have robust designs ready for not only the automation of our pilot line, but also scale up to our mega factory. And the mega factory, as we've designed it so far, is expected to go into the UK BIC. So that's an existing lithium-ion facility. And what we want to demonstrate there is the degree of compatibility of our process with an existing mega factory asset. And then beyond that, similar model to what we've got for Stereax, moving into licensing on the larger scale. So in order to manage risk and make sure that the implementation in the mega factory and indeed the gigafactory beyond that is as trouble-free as possible, we've kicked off a series of funded programs. These are all grant supported largely through the APC, which is the Advanced Propulsion Centre, which manages grant funding on behalf of BEIS in the UK. And the programs that we've got here start with Solstice, which has now come to an end. That's the one we were doing with Comau on process design. We've currently got one called TDAP in progress, which is all about optimizing the forming protocols for solid state and making sure that we understand the minimum forming cycling that we can put ourselves through, and therefore minimizing capex and ongoing energy costs. Thirdly, a program that we've just started, which is called Bus 100, which you may have seen announced, which is all about assessing the economics for implementation in the UK BIC, making sure we can hit a price point there that meets expectations of customers. And then finally, one that's going to start shortly, which is a step about vendor equipment trials. So a series of grant-supported programs, in total about £500,000 worth of grant support there, linked to tech transfer to mega scale. So what does the commercial demand and our commercial interactions, what does that look like? Well, we've now met with most of the global automotive OEMs across different sectors, not only supercars and hypercars, but also some of the mainstream manufacturers. What we need to make sure is that we choose the right partners for the next stage of our development. And we will be issuing commercial quotes for larger scale sampling when we hit P1 at the end of this year. There's plenty of demand for that. In fact, 2 OEMs have already signed evaluation contracts in anticipation of P1. So we're actively engaging with those companies now, and we expect some of these initial assessment programs to then mature into closer relationships as we move into implementation of larger scale production. So I'd now like to hand over to Steve, who's going to give a bit more of an explanation relating to some of the financial aspects of our reporting.
Thank you, Graham. This is the financial results. This is a distillation of the 55 pages that were released by RNS this morning. So just trying to pick up the key factors from that release. This is for the 12 months ended 30th of April 2022. The first thing to note is the slight reduction in turnover, primarily in relation to grant support. A number of the larger grant funded programs that Graham was alluding to on the earlier slides that we had with Honda, JLR, and McLaren come to a conclusion at the end of the last financial year, or just the start of this, and some of those smaller tailored programs have kicked off. But this was something that we undertook fundraising at the start of the year last year to make sure that we could mitigate against, because we were aware that the government had a number of priorities other than funding R&D development. So that turnover reduction obviously fed down to the bottom line, as did the increased R&D spend. Again, off the back of that fundraise last year, we had the support to be able to increase our spend on R&D from about 2.3 million to 4.8 million. Now, our biggest cost is our staff. So about £1 million of that increased R&D spend is in relation to the 13 additional heads that we employed in the period. It is also associated with the increased materials costs, utility costs for running experiments, and a number of consultant-led activities that ensured that we could get to the answer more quickly, trying to develop everything in-house. It wasn't just R&D spend. Obviously, we had the expansion of operation activities associated with the commissioning of the Stereax fab. Some of those are one-off costs that contributed to that increased EBITDA loss. What you don't get in the EBITDA number is the R&D tax credit. We actually get money back from HMRC for undertaking qualifying R&D activities. And the amount that we've got shown in the accounts is about £1 million reclaim. We engaged some experts in the field to make sure that we maximise that opportunity, and it could be as much as 1.3, 1.4 if everything goes to plan. So we've still got a very strong balance sheet. We've got 23.4 million on the balance sheet at the end of the period. As I mentioned, the increase over the prior year is obviously the fact that we raised some money in July, and some of the reduction is obviously associated with CapEx spend, as we've completed the CapEx spend associated with the Stereax raise, which we undertook in 2020. Thank you.
Thanks, Steve. So maybe just to round off actually with a few words about how we have reinforced our management team. Some very energetic and experienced characters have joined the team. Those of you who came down to a Capital Markets Day in December will have met them. So Brendan is our Goliath Operations Director. He has had a glittering career at BMW, where he was Group Level Operations Director. And perhaps more importantly, the Manufacturing Director at the UK BIG. And therefore he brings a wealth of experience in terms of scale-up implementation, making sure that actually we make the right choices around equipment vendors and the implementation of that program. Robin has also joined us. He's now our VP of Product Development. He was previously at SPI Lasers, which was a spin-out from the University of Southampton that was subsequently sold to Trumpf Lasers, one of the world leaders in laser manufacturing. And more recently, he has been at Informatics, which was a company sold to Suez, the big utilities company, and he developed a product around water distribution network management. So Robin's got a load of experience around new product development and is a firm hand on the tiller of our NPI programs. Very good. Well, that wraps up the slides that we want to cover. So I think we're now going to move into the Q&A session.
Yeah, Graham, Steve, thank you very much for your presentation. Ladies and gentlemen, please do continue to submit your questions just using the Q&A tab situated in the top right-hand corner of your screen. But just while the company take a few moments to review those questions submitted today, I'd like to remind you that a recording of this presentation, along with a copy of the slides and the published Q&A, can be accessed via your investor dashboard. Graham, Steve, we received a number of pre-submitted questions from investors, and I want to start off the Q&A session with these. The first one reads as follows. Morgan Stanley recently said, "We need more batteries everywhere now. Why can't the Goliath commercial timeline be condensed in light of the current global requirements?"
Yeah, that's a great question. Well, we raised funds last year in July of 2021 to allow us to accelerate our program. So we said we would invest £10 million in Goliath R&D, as well as £5 million in automating our pilot line. And frankly, we're deploying these funds as rapidly as we can.
Perfect. Thank you very much. Just turning to the next question. Investors received a message saying that it is taking longer than previously anticipated to ensure that product batches reproducibly meet specification. Could you please shed some light on this?
Yeah, so this statement relates to our Stereax product, which we transferred to fab production in 2021. The principal challenge that we met there related to qualifying the performance of a piece of equipment that we previously called Tool 1. So this is the equipment that's used to make the Stereax cathode materials using reactive thermal evaporation. Despite using a modeling tool prior to fabrication to make sure that we make the right design decisions, it turned out that the process conditions, so by that I mean things like temperatures, pressures, and deposition rates, they needed to be recalibrated relative to the values that we'd used successfully on our pilot line for a number of years. And unfortunately, this recalibration delayed our process qualification until May of this year.
Thank you very much. Just moving on to the next question, which reads as follows. It seems like most, if not all, SSB companies are chasing the car battery. I know that ILIKA is as well. But do you have any more competitive advantage or niche in the Stereax line than you do in the Goliath line of SSB? Will the Stereax line be first to market for ILIKA?
So yeah, we believe that both of our product lines, Stereax and Goliath, are differentiated relative to the competition. However, it is the case that the competitive landscape for Stereax is less intense than it is for Goliath. There are many companies that are seeking part of what will become the largest market for batteries in the world, which is the EV market. The Stereax line will be the first to market for ILIKA, so we expect to start commercial sales in 2023 for that product line. But that's not to say that Goliath won't have its own niche. I don't personally believe that solid state is a first past the finishing line opportunity. I think there will be a diversity of solutions that will continue to be used within solid state batteries. And actually, the existing battery industry is a case in point here, whereby despite the fact that lithium ion cells have been around for over 30 years now, there are still very different chemistries used for different applications. And even within the automotive industry, you look at the different cathodes that are selected by manufacturers. So LFP, which is used extensively in China, so it's lithium iron phosphate, NCA and NMC, which are used a lot in the automotive industry, LCO, which is used in consumer electronics. And so when you look at the competitive landscape for solid state, there's actually quite a few different technologies that are being developed. Many of the technologies that are closer to market are sort of hybrid solid state batteries where they have a high polymer content in order to give the cells the ionic conductivity they need to be useful. Or they use sulfide-based electrolytes, which again are relatively straightforward to build into a solid-state battery with their high ionic conductivity and their malleability, but with the drawbacks of being air and moisture sensitive. And then, of course, the oxide electrolytes, which are the ones that ILIKA is developing, which are arguably more difficult to perfect, but have the advantage of a straightforward manufacturing process that's very compatible with existing lithium-ion fabrication techniques. And then different anodes too. So I guess, my point is that I accept that it's competitive in the Goliath landscape, but nevertheless, I think we have an important niche there.
Perfect. Thank you very much. And the final pre-submitted question reads as follows: Can you please tell us what your current watt to kilogram performance and number of cycles is compared to your competition, and how you compare on a like-for-like basis with other chemistries from BYD and other US startups?
So, I have to apologize. It is quite difficult to be categoric about this because a lot of these technologies are still in the development stage, and frankly, the companies that are developing them don't really want to make the prototypes broadly available for analysis and comparison, because of course you run the risk that you'll end up with IP leakage before the product is fully formed. However, we plot our watt hours per kilo performance on the S-curve that we were showing earlier. So that shows that we're approaching D2, which is at 100 watt hours per kilo, and we've achieved 500 stable cycles. I think that puts us broadly still in the competitive cohort of companies that have got a technology which is worthy of further development and ultimately adoption. So I think that we are, in that list of companies that are viewed as credible players. In terms of other companies you could look at, so QuantumScape, Solid Power, and SES in the US, as well as Factorial, I think are interesting companies that have also received validation and investment from other strategic investors.
Perfect. Thank you very much. That actually concludes the pre-submitted questions. But as you can see, we've received a number of questions throughout today's presentation, and thank you to all the investors for submitting those. Could I just ask you to read out the questions and give responses where it is appropriate to do so, and then I'll pick up from you both at the end.
Yes, thank you. Just reviewing them now to take a look at which ones cover new ground. So there's a question here: why is Stereax product qualification being delayed? So I think we've covered that one earlier on. When will it be completed? So the product qualification will be completed towards the end of 2022. And do you have any confirmed customers? Yes, so we've shown you that list of customers there. And by the way, all of those customers have already bought evaluation samples from our pilot line, and they have orders that we need to fulfill for our M300 product, which is coming off our new fab. So there's plenty of, understandably impatiently waiting customers who are waiting to incorporate our products into their own products. And wafer yields are really what we're optimizing at the moment. So moving from yields in the order of about 50% through to ultimately yields as high as 95% by the time that we have finished that process optimization. So the next question is, what are you forecasting sales to be in 2023? So actually, for the financial year that we just started, which we refer to as financial year 2023, which is the year that ends at the end of April of next year. Steve, what's the guidance that analysts are giving?
The analyst guidance on that is around the million mark. We talked earlier about how much of that is covered already by grant funding, which is probably around half. And then there's quite a piece for the back order of Steve just discussed.
Oh, and now that we've got Steve on the line, the next question is interesting. It says that the CFO departing at such an important time for the company is hardly a vote of confidence in the company's prospects. What should investors make of this? Well, Steve, I think you've been given an offer that you couldn't refuse. Unfortunately, when you have success as a management team and deliver on a plan, and shareholder growth over the years, then you acquire experience which becomes of interest and is in demand. And Steve got one of those Friday afternoon calls and was made an offer that he can refuse. Is that fair enough?
I think that's right. It's a company that is a private company looking to do the sort of path that ILIKA has followed, and they were making an offer, as I say, that I couldn't refuse.
And just to give you some comfort on that, we did launch an executive search program as soon as it became clear that Steve was moving on, when we found out earlier in the year. And that's now coming to a conclusion with a short list of very interesting candidates who have got the necessary skills in order to continue to support the company and build on the strong foundation that Steve has laid. So the next question is here: are you the global leader for electrostatic solid-state batteries? And who's your competition in the sector? Well, I'd like to think actually that we have created a very interesting solution for the electrostatical applications. There are some other companies who are active in thin film miniature solid-state batteries, some of them in the US, but I believe that we have invested significant funds in making sure that we have a very compelling solution, which puts us in a leadership position. Just having a look at some of the other questions we've got here. So the next one is: the Stereax scale-up started well, but it's taken longer to get fully operational. Equally, medtech takes a long time to get regulatory approval. So when will the Stereax line be operating at 100% capacity? Yeah, so that's right. So our approach is to aggregate demand from medtech customers and make sure that we have sufficient demand in order to fill the fab as quickly as possible. Our guidance is that from the completion of process optimization, that we'll be able to aggregate enough demand to move the facility to full capacity within a couple of years. So that will put us into 2025. And then beyond that, it will be an opportunity to move into the licensing model. So another question here: publicly available information on Goliath technical performance is extremely limited. How can investors benchmark Goliath against other competing SSBs? Yeah, I think, speaking frankly, it's a challenge for the sector. Not many of the solid-state battery developers have got categoric data sets that can be compared on a like-for-like basis. But the fact that most of these players have got commercial interactions with organizations from the sector can give them some validation and comfort that actually progress is being made towards a commercially viable product. So a question here: do solid-state batteries perform better than lithium-ion batteries in cold and very cold conditions? So honestly, I think the answer here is no. Actually, low temperatures are difficult for all types of lithium-ion batteries. And it's to do with the mobility of the lithium ions and their ability for the lithium to transfer from one electrode to another. So effectively, when you use a battery, you are releasing the lithium ions from the anode back into the cathode. And that release process, the kinetics of that are reduced in cold conditions. So effectively, what the solution is to engineer the batteries so that it's large enough so that there is adequate current from the whole pack to be able to start the motor. And once you start to cycle the batteries, actually they warm up. And within a few cycles, you're generating heat that allows the battery pack to perform. So, this isn't a game changer. It's just a case, it isn't a showstopper, is what I meant to say. It's a case of making sure that the engineering of the battery pack is adequate to support the operating environment.
Yeah, there's a question from Richard A. Is the prior period comparative period 21-22? Actually, that's an error in this draft. It should say 2021. So well picked up. That's the first person who picked that up today.
Apologies for that.
Yeah, apologies.
So a question here, with a market valuation of less than 100 million US, the company must be vulnerable to a US or Asian takeover before the real value of the company emerges. What do you intend to do to address this valuation gap? Well, the reality is that as a company, we don't have total control over our valuation. However, we have got a published plan that we're sticking to, which is the commercialization of Stereax and the formation of commercial partnerships that support the rollout of that technology. And then on the Goliath side, maturing that technology as quickly as our resources will allow. And again, formation of commercial partnerships to validate the technology and move it through to commercialization. So question here, will there be the need for additional funding, or will the current cash be sufficient to meet your requirements? So when we raised the funding for Goliath last year, we said that we were funded through to manufacturing readiness, which basically puts us to a point where we are ready to implement the technology at mega scale. Now, we are not actually funded for implementation of a mega factory. When we wish to proceed with that, we will need to raise additional finance. And the plan at present is to do that in combination with a strategic investor, so probably an automotive OEM, that's interested in participating in the commercialization of the technology. Government grants, because this type of investment is nicely aligned with UK industrial strategy, as it is actually with the industrial strategy of many countries. And then the remainder, perhaps the remaining third of the investment from existing and potentially new financial investors. And the magnitude of that investment we currently estimate to be in the region of about £60 million in total. So a third from each of those three sources that we've highlighted. So there's a question here actually, which is slightly different, which is on our licensing model. Will it be based on volumes only, or a combination of volume and annual payments? So we actually have an NED called Dr. Monica Biddulph on our board, and Monica is an experienced alumni of ARM. So she was a senior manager at ARM and is a licensing expert. And so the model that we've discussed with her, that we've also started indicating to parties who've shown initial interest in licensing Stereax, is that we would have a license issue fee, and then we would have ongoing annual payments. First of all, minimum annual payments associated with the volume of production, which can then be exceeded by a percentage payment on the product sales associated with the IP. So indeed, it would be an upfront payment and then annual payments that roll forward after that. And the scale of those payments would be dictated by the breadth of the license that we negotiate. So, geographical breadth and product breadth. So I think that probably wraps up most of the questions that we've got for today.
Yes, Graham, Steve, thank you very much for that. I think you've addressed those questions you can from investors. And of course, the company will review all questions submitted today and will publish those responses on the Investor Meet Company platform. But just before redirecting investors to provide you with their feedback, which I know is particularly important to you both, Graham, could I just ask you for a few closing comments?
Well, I'd just like to thank everybody who's taken the time to register for this presentation, and thank in particular those investors who continue to support the business. And I look forward to catching up again in due course.
Graham, Steve, thanks once again for updating investors today. Could I please ask investors not to close this session, as you'll now be automatically redirected to provide your feedback in order that the management team can better understand your views and expectations. This will only take a few moments to complete, but I'm sure will be greatly valued by the company. On behalf of the management team of ILIKA PLC, we'd like to thank you for attending today's presentation, and good afternoon to you all.